kernel module is a self-contained driver library file. In order to keep the Linux kernel light and agile, Linux uses modules instead of compiling all their features straight into the kernel itself. That way we can add features as on demand because modules can be loaded and unloaded as needed. And all this can be done without having to reboot the system. Today we're going to learn how to install, configure, and monitor kernel modules. Modules that support a kernel are located in the /lib/modules directory. Each kernel on your system will have its own subdirectory here. My Ubuntu virtual machine, I am going to do ls/f/lib/modules. One thing to be aware of that some distributions link the /lib/modules to the /user/lib/modules. As you can see from this CentOS example here, it's the same file regardless of where it's located, as indicated by the ID number out beside it, 491. On older Linux distros, there was a single config file located at /etc, and it's called /modules.conf. In newer Linux distributions, you'll see either a /modprobe.d or a /modules-load-d. These contain the config files generated at system installation of the kernel. Sometimes a module failure will trigger a kernel message. You can use the dmessage command to view the kernel messages. At boot, a snapshot of the kernel ring buffer is stored in a log file that is typically located at /var/log/dmessage, and the dmessage command will let you read the current kernel ring buffer. The example on your screen is dmessage being run on a CentOS, and here I piped it to grep for I for inclusive driver, regardless of the capitalized or lowercase driver, and those are the results from there. And I'll run dmessage real quick on my Ubuntu server. Here we are on my Ubuntu server, and I'm going to do sudo, since I'm not logged in as root, dmessage, and with no pipe and without filtering the dmessage log very long because it's constantly updated. Even here I can do something like sudo dmessage pipe to grep I for capital or lowercase and driver, and I get a similar result. The lsmod command displays the status of modules that are currently running. For an example, here on the CentOS machine, you can see the module, you can see the size, and you can see if it's how many processes are using it. And if it's being used by another kernel, you'll have the kernel name out there to the right. To find more information about a kernel module, you can use the modinfo command. You have to remember you have to use sudo or be logged in as root to use any of those commands we're mentioning. So back in Ubuntu, I'm going to clear my screen real quick, and now I'm going to use the sudo lsmod command. And there are my modules, and I see each line is a different module, and you see its name, you see its size, you see how many processes are using it. If another kernel is using one, it has the name of the other kernel. Now let's say I want more information on one of these modules. What I'll simply do is sudo mod info, and then the name of the kernel module. Let's take bridge for example. Modinfo gives me the file name to the bridge module, and it gives me the version, which can be helpful with a particular version. Typically, Linux will automatically load the kernel modules you need for your system, but sometimes you want to manually install a new module so that you can test the configuration on your system. To do this, you would use the insmod utility. This installs a single module into the kernel, but to use this utility, you have to provide the absolute path to the module file, and it does not load any of the module dependencies for you. The modpro command is a lot easier to use because all you need is the kernel module name, and it will automatically load the dependencies for you. And this is sample on your screen. This is CentOS. I'm using modprod/v to show me what's going on in the background. And the module kernel that I'm loading is dm_mirror. And as you can see, it loads dm_mirror, and it also loads the dependencies that are needed, such as region-hash. Now, if you're trying to troubleshoot a piece of hardware connected to your machine, the dep-mod command is very useful for troubleshooting that. What it does is it scans the system looking for hardware that was not automatically detected, and then it adds the dependencies that were needed and updates the appropriate module.dep file. And I'll pull that up on my Ubuntu machine real quick so you can see how it looks. Here I am back in Ubuntu, and I'm simply going to type in sudo dep for dependency mod, enter. Right now it's searching my system for any hardware that was not automatically detected. Sometimes it takes a while. In this case it didn't take that long, but it also didn't find anything. It's always a good idea to remove any modules that you added yourself when you're no longer using them. To unload a module with no dependencies, you would simply use the rm for remove and mod command. For example, to remove the kernel module joy dev, you would do rm mod -v to see what's going on in the background and joy dev. I'll pull it up real quick on number 2. Alright, so let's say we're going to remove a module. We'll need sudo remove mod, and let's say I'm going to do v to see what's going on in the background. And let's say I have a module called joy dev, which I don't believe I do, so it should return just a blank line. If that module was actually on there, I would see the process of it removing it, and then the command line would show up. Now, after removing a module, it's also always a good idea to do sudo ls mod and then the name of the module to make sure it's not still there. And here, all it brings back is the ls mod command. It doesn't find the module. Now, if you need to remove a module that has dependencies, to get them all in one big swoop, you would use the mod probe utility with the /r switch for remove. For this example over here, for CentOS, it is sudo mod probe /r for remove, v to show what's going on in the background, and then the module name, which in this case is dm_mirror. And then as you can see from the output, it removes dm_mirror along with dm_region hash, which was a dependency of dm_mirror. And again, you should run the ls mod and the module's name to make sure that the module has been removed after this. So now Linux Plus review question time. When you install a USB device on a Linux system, it appears that the device is not being detected. Which of the following is the best command to troubleshoot this particular situation? You have ls mod command, the mod info command, the dmessage command, the dep mod command, and the ins mod command. So pause the video if you need to go back and look for an answer to this question. It was mentioned earlier in the presentation. And the answer is dep mod command, because the dep mod command scans the system looking for hardware that was not automatically detected, then adds the needed dependencies and updates the appropriate modules.dep